All right, kiddos. Hope everyone's doing well. I'd like to continue thinking about lines, but in a little bit more of an algebraic way, in particular by finding equations of lines. So we talked a little bit about slope between 2 points, distance between 2 points, the midpoint. Now we're going to generalize a little bit more, talk about linear functions and the equations of lines. So there are lots of forms of linear functions. Perhaps you've seen some of these before. This is probably the most famous. It's called slope because m is the slope, intercept because b is the y-intercept of that line. There's what's called the standard form, and perhaps this is review, perhaps it's not. And this is called standard form. Notice how x's and y's are on the same side of the equal sign, right? Of course, you can always manipulate standard form to get slope-intercept, right? You can go back and forth algebraically. But the equation of the line that I'd like to have you consider today is what's called point slope. And it looks like this. Y minus y1 equals m times the quantity x minus x1, right? And this is a helpful way to find equations of lines in a number of situations, right? And so for this particular look, m is the slope, just like it is in slope-intercept form. So slope m, and through the point x1, that's the value, the x value of the point it goes through, and y1 is the y value of the point. Right? So through the point x1, y1. Okay? Let me show you how this is usable, right? Now, of course, what makes a line is that it grows or shrinks at a constant rate of change. We have constant slope, that's why it's straight. Right? So if I look over here, if I graph, first of all, I'm going to turn my plots off. But if I graph a basic 3x plus 1, 3x plus 1, what you'll notice is that the slope will be 3 and the y-intercept will be 1, right? So here we go. Oh, let me change the window. Sorry, in stats mode. So this particular line here is going to, for every, here's my y-intercept, 0, 1, noted by this plus b. And it's going to rise 3 for every one it's moving over 1, right? And so we can see that a little bit better in the table. Let's make sure it's set up properly. We're going to start, let's start at -3. We'll go up by 1s and we'll go to auto. And what you can see in the table look for 3x plus 1 equals y is you can again see the slope of 3, right? Plus 3 over 1, plus 3 over 1, plus 3 over 1, plus 3 over 1, plus 3, plus 3. And the slope between any 2 points will always have the same ratio as 3 over 1, right? So it's rising 3 for every 1 it's traveling over, or it's rising 6 for every 2 it's traveling over, okay? So that's just a little bit about lines, right? And that's why they look straight. They look straight because their slope never changes, right? That's what makes a line, okay? So let's consider this example. Let's try to find the equation of the line, between these 2 points. Let's say, I don't know, 2, 6, and let's make it nice and easy, 6, 12. Okay? And so what I'm going to do is I'm going to use this point slope form, okay, which requires 2 things. I need to know the slope, m, and plug it in here, which I can get, and I need to know at least 1 point it travels through. But I got that. I have, in fact, 2 points this line goes through, right? So what I'm going to do is I'm going to find that slope, and I'm going to create a little more space here. Put this problem I'm trying to solve up here, and I'm going to use this line. Okay. So the first thing I want to do is find the slope between the 2 points. And you guys recall that slope is rise over run, right? It's the ratio of increase or decrease over running. And running goes left to right, right? So it's really change of y. So it's 12 minus 6, change of y, over, and since I started with the y variable of 12 on top, I have to start with the x 6 on the bottom, right? That's over that 6 minus the other x value 2, right? 12 minus 6 over 6 minus 2. The change of y on top from 12 to 6 or 6 to 12, change of x on the bottom, right? Just be consistent. If I start with 12 on top, I start with 6 on the bottom. And of course, these numbers are not too bad, so it ends up being 6 on top. 12 minus 4 is 6, and then 12 minus 6 is 6, and then 6 minus 2 is 4. All right, and I'll simplify that to, that's right, 3/2. Okay. So what that means is this line, this magical line that I'm looking for every 2 it moves over, it's going to go up 3. Okay, it's going to rise 3 for every 2 it runs from left to right. Or it's going to rise 3/2 for every 1 it moves over. Right? Or it's going to rise 6 for every 4 it moves over. It's all proportional. Okay, it's all the same ratio. Okay, so what I can do now is if I'm going to use this point slope formula, I'm going to take that m, and I now know the slope of the line I'm looking for. It's 3/2. So I just plug it right in there for m. Okay. Now I also know in fact I know 2 points through which this line travels, so I just pick one of them. So I'll pick 2, 6. Doesn't matter which one, the line goes through both. So I'll take the x value of the point, either one that it goes through, 2, and I'll put that in for x1. And then I'll take that corresponding y value, put it in for y1, right? So the x1 is 2, the y1 goes here, right? It's the coordinates x1, y1 of one of the points that go through. Can you use 6, 12? Sure. 6 goes here, 12 goes there. 6, 12. But just pick one of the points, doesn't matter. Since 2 and 6 are easier to work with, I'm going to pick 2, 6, right? So I'm going to take this little point here, and I'm just going to replace it with 2, the x value of the point, one of the 2 points it travels through. And since I use the 2, I have to use the corresponding y value for that same point, 6. Okay. And so now, looky here. This is really the equation of the line between these 2 points. Now, it doesn't look pretty, but I can deal with that, right? I can clean it up, right? And the way I'm going to clean it up, I'm going to distribute the 3/2, and I'll add the 6 and put it into, by isolating y, slope-intercept form, if you want to, because most kids like that look, right? So now what I'm going to do is I'm going to distribute first the 3/2, so I still have y minus 6 on the left, and that becomes 3/2 x. I'll just write it as such, minus, and then 3/2 times -2. What does that equal? 3/2 times -2, well, the 2's cancel out, it's like -2 over 1, and I just get minus 3. Fair enough? Now, one more step to isolate for y. I'm going to add 6, and when I add 6, this becomes, on the right, plus 3. Okay? Now, these are the same. I bet you $1 million they're the same. Okay? The same line, different form. Okay? Let's see what that looks like on the graph, right? So here are my, either way, equations of the line. So I could say, okay, what's the y-intercept of this line? Well, you would say, well, it's 3, right? It goes through the point 0, 3. Or I could say, what's the slope of this line? And you would say 3/2, right? I already found that. Okay? Let's see what it looks like on the graph. So I'm going to go to my stat option. I'm going to put these 2 points in, 2, 6, 2, 6, and then 6, 12. And we'll go over this calculator work at a later time, but this is just a nice way to verify what we're doing. The point is 2, 6, and then the other point is x value 6, 12. So I'm just putting those 2 points in. And then what I can do is I can use my calculator to do that work for me. So I'm going to press stat, calculate the linear line basically between those 2 points. And what do you know? It's A is my slope, 1.5. Oh, that's the same thing as 3/2. My B, my y-intercept is 3. It's the same thing. Right? So what I can do is I can look at those 2 points if I want to. Actually, I don't even need to do this, but whatever. I'm going to do it anyway. Turn my plots on. I got to actually erase that. And I'm going to put in my new function, 3/2 or 1.5, same thing, x, slope of 3/2 or 1.5, plus my y-intercept of 3. And I'm going to turn my plots on too, so I can see those 2 points initially, right? And then I'll just graph it up and see what we got. Those are the 2 points. Oops, let's get a little better view. I'm going to zoom out a little bit, but I'm going to let the calculator do it for me. Here are my 2 points, and here's the equation of that line that I already found. And the calculator verified. Here's 2, 6. Here's the point 6, 12. Surely that line goes through both. Remember, a line is determined by 2 points. 2 points determine one line. I found the equation of that one line. through those 2 points, right? One line through 2 points, right? And the equation of the line is 3/2 x plus 3, or 1.5 x plus 3. Okay? Thanks for listening. I hope you have some good notes. We're going to use this tomorrow in class. So what we did, to reiterate, from 2 points, we found first a slope, which we know how to do, and then we use the slope, and in this case, point-slope form of a line, to find the equation of the line through those 2 points, and then we put it into slope-intercept form because it's a little bit better. Take care. Good luck. Answer questions tomorrow.